Welcome students. Today we learn about another example of relative motion, which is river boat problem. In previous classes we have already done several topics like flag problem, umbrella problem. Today we learn about river boat problem. Initially we are explaining you some things which you has to know. Okay, some top things are that I am taking two cases, 1, 2. Okay, in this case, this is the velocity of river Via, and this is a boat whose velocity VVR, which is relative velocity, which is velocity of boat with respect to river, velocity of boat with respect to river. Okay, velocity of boat with respect to river, which can be written as velocity of boat minus velocity of river. Here we can easily find velocity of boat will be velocity of boat with respect to river plus velocity of river. Okay, in this case velocity of river is in that direction and velocity of boat with respect to river is also in same direction of flow of river. Therefore, this is the case of downstream. Which case? Downstream. Here I am taking that velocity of river in that direction and velocity of boat with respect to river in that direction. Therefore, this is the case of upstream. Okay, let's start. We are taking several cases in river boat problem. Okay, I am taking several cases. And now we start first case. Case 1. In river boat problem, we have to take several cases like shortest path, shortest time, and so on. First one I am taking, this is a river whose width is d and the velocity of river is via in that direction. Okay, and for first case is shortest path. Shortest path. If a boat will move from point A to move another side of river, for shortest path, this will be shortest path. The shortest path will be D. This will be shortest path. Okay. In this case, if VR will be 0, let VR will be 0. If velocity of river will be 0, then I am driving boat and I will move in perpendicular to river with velocity of boat V with respect to river and go to another side, and shortest path will be D. We have no problem. But if velocity of river is not 0, then we have to do something. Here velocity of river is VR. Okay, we have to go in that direction. We have to go in that direction for shortest path. This is the basic need. For shortest path, we have to move in that direction. Okay, velocity of river is in that direction and we will take velocity of boat in that direction. Velocity of boat VBR. VBR. Velocity of boat with respect to river with angle theta to perpendicular. Why? Because velocity river is in that direction, velocity of boat with respect to river is in that direction, therefore the net velocity will be in that direction, because we need net velocity in perpendicular direction of river. Okay, therefore we will move in some particular angle theta to perpendicular of river. Okay, for shortest path. Therefore the component of VBR in y direction or perpendicular direction will be VBR cos theta, and in x direction will be VBR sin theta. Okay, and another confusion is or are there, if velocity of boat with respect to river is greater than velocity of river, there then we can achieve shortest path only. This is the condition for shortest path. Why? Why? Our basic question. Because if velocity of boat with respect to river less than velocity of river, then velocity of boat will flow in that direction, and this can't go to that point. This is initial point A and this is point B. We can't reach point B if velocity of boat with respect to river will less than velocity of river. Then it will go something in here. If velocity, I am explaining here, if velocity of boat with respect to river, less than velocity of river, then the net velocity in x direction will be in x direction, in that direction. The net velocity in x direction will be VR minus VBR sin theta. Therefore it will go by achieving some displacement x and reach here point B, not the shortest path. This will take some more than shortest path. Okay, therefore for shortest path the initial condition will be that velocity of boat with respect to river should be greater than velocity of river. Okay, I will explain this topic also further. Initially, now I am going to start shortest path. Therefore this is the basic condition. Velocity of boat with respect to river should be greater than velocity of river. Okay, then होगा क्या? If we write equation in x direction, in x axis, if we write equation on x axis, then we clearly see that velocity of boat with respect to river of sin theta, VBR sin theta, will be equal to velocity of river. This is velocity of boat with respect to river sin theta, VBR sin theta will be equal to velocity of river. Okay, therefore this is the first equation. Okay, and sin theta will be BR by VBR. Okay, and on y-axis, let time taken to reach from point A to B is t. Okay, then uh, time period will be d by v vr cos theta on y-axis. Okay, we can easily see that. Okay, time period is that. If we write equation on x-axis in term of time, we can easily see that uh, displacement is 0. So we don't write it. Okay, therefore I am going further. This is the shortest case. Shortest path, for shortest path, sin theta will be that, and time period is time. Or shortest path will be here, t is equal to t into v br cos theta. Okay, ठीक है. Now the another case is shortest time. Shortest time. Shortest time. For shortest time in river boat problem, we have to move in perpendicular direction. We can easily see that for shortest time we have to move in perpendicular direction. Okay, we can easily go to other side by achieving minimum of time. Okay, we are in that direction. Okay, some that direction will be in that direction, v net. Okay, and we will reach at some point B. X there. Okay, this is sufficient. If we write the equation on y-axis, we can easily see that on y-axis the time period will be d. If width of river is d, then time period will be d by v vr. Okay, and on x-axis, if we write equation, then x is equal to vr into time period, because this is perpendicular, the component of vbr on x-axis is null. Oh, x will be vr into time period t, because for going from point A to point B it will take time t. We can replace it from here. So x will be vr into time period is t by vbr. This will be horizontal displacement. Horizontal displacement. Okay. Now I am taking an advanced topic. Another case. I am taking a third case. Advanced topic है. Advanced topic. Velocity of river is vr. Width of river is t. Okay. And it is moving with velocity v vr on particular angle theta. The component on y-axis will be vbr cos theta, and then on x-axis will be vbr sin theta. Okay. In first case, for shortest path we take the condition vbr greater than VBR. Now I am taking if VBR less than VR. Okay, this case what will happen? Now I am taking that. Okay, कंडीशन क्या है फॉर एडवांस टॉपिक के लिए? कंडीशन हम ले रहे हैं रिवर बोल्ट प्रॉब्लम में, इफ वी VBR is less than VR. Velocity of boat with respect to river is less than VR. For example, if 2 meter per second, velocity of boat with respect to river is 2 meter per second and velocity of river is 4 meter per second, then this is the example of this case. Okay, not shortest case, not shortest path. Okay, for that particular case, what will happen? Let write the equation on y-axis. On y-axis, we can easily see that time period will be d by VBR cos theta. This will happen. Okay. On x-axis, the net velocity will be in that direction on x-axis, because VBR is less than VR, therefore boat will move in that direction. Therefore net velocity will be in that direction. The net velocity on x-axis क्या होगा? On x-axis VR minus VBR sin theta. Therefore on x-axis, if I am writing the equation, then it will be something, and it will reach from point A to some point that. This will be point B by achieving or by traveling some displacement x. Okay, this is point A and this is point B. Therefore on x-axis, if I am writing equation, then the x will be time period into VR minus VBR sin theta. Okay, this will note down it. In shortest path, we have no displacement on x-axis because we have to move on perpendicular direction, but in this case this will happen. Okay, this will happen. The time period x will be the horizontal displacement. Horizontal displacement will be time period into VR minus VBR sin theta. Okay, or time period can be replaced from there. X will be d by VBR cos theta into VR minus VBR sin theta. Okay, this will be equation. Now I am further taking some point on this topic. I am explaining it further. X is what? D by VBR cos theta into VR minus VBR sin theta. This is this is x. I am saying that we know that x cannot be 0. X cannot be 0. This is, if x 0, then it will be case of shortest path. But we know that x cannot be 0. But we can minimize x. We can minimize x. Okay, how? By using derivation, we can take derivative of this of x with respect to theta, and we can easily find out the minimum value of x. Okay, for that we can easily find the shortest path. I know this will not be equal to d, but this will be nearly equal to d, more than d, but nearly equal to d, because x will be minimum. For that we can take derivation of this. If I am taking derivation of this with respect to theta, dx by d theta will be 0 for minimum value of x. Okay, what will be derivative? D by v be all cos square theta, cos theta into EVR. Okay, 0 minus cos थीटा पूरे ले लेते हैं. ओके, पूरे ले लेते हैं फॉर डेरिवेशन v by u. ओके, तो it will be cos square theta 1 by v r and cos theta into 0 minus v r cos theta minus, this will remain same, vr minus r sin theta into derivative of this cos theta minus sin theta equal to 0. If we solve it, let's solve it. If we solve it, we can easily see that minus r cos square theta minus plus vr sin theta minus vr sin square theta equal to 0. Okay, this will become vr. So vr sin theta equal to vr. This will, sin theta will be vr by vr. Sin theta will be that. Okay, then what is the value of x? What is the value of x? X was, time period is what? Time period is d by vr cos theta into vr minus vr sin theta. Okay, this was the value of x. We can replace sin theta and cos theta from here. Okay, and we can find easily the minimum value of x. Let's solve it for formula, general formula. Cos theta will be from here is 1 minus vr square by vr square, vr square minus vr square by vr. This will cos theta, and we can put both in that equation. We can easily find that d by vr and under root vr square minus vr square by vr. This is vr. Okay, and here vr minus vr into vr VBR square by VR square by VR, और this will VR से VR कट गया and इसके रूट से इसका रूट कट गया, then x will be d by VBR under root VR square minus VBR square. This is the general equation for minimum value of x in advanced topic. The condition was that if VBR less than VR, if VBR is less than VR, then minimum horizontal displacement will be d by VBR under root VR square minus VBR square. This is the general formula. We can find several things in river boat problem. We have several cases, we have several examples. We are taking an example of that advanced topic. If VBR in question is given that velocity of river is 4 meter per second and velocity of boat with respect to river is 2 meter per second. Okay, it moves with angle 30 degree with perpendicular. What will be horizontal? What will be minimum value of horizontal displacement? Okay, what will be? We can easily use that x minimum is d, if d is 100 meter given, okay, 100 by velocity of boat with respect to river is 2 meter per second, 2 under root 4 square, 4 is 16 minus 2 square 4, 12 root of 12 under root 12 or 50 under root 12. This is x minimum. We can find several things in that time period. What will be time period? We can find easily. But important question was minimum horizontal displacement. Thank you very much. If you like it, then share it. I will explain several things in various videos. Thank you very much.